still morning, so good morning, everyone. Before we start, I'm going to go through our assignments that are coming up and see if there's any questions about the change up that we're having for today. So, on Thursday, there are a bunch of reading quizzes due. If you did not complete Chapter 3 and 4 reading quiz, definitely do that. Then there's a Betancourt and Ulwick quiz and a Chapter 9 reading quiz. So a bunch of reading quizzes due. And then on Friday, a memo is due, which talks about having your project charter and your Gantt chart. So you're going to want to make sure that you meet with your team this week to work on that, and also set up a meeting time so that you can meet weekly with your group and start working on all those team skills that we talked about. So you're in the forming stage of your team, figuring out roles, when you're meeting, how you're going to organize things, all of that stuff. And if you need some help, please let us know. We're more than happy to help you. You're going to want to have a Google Drive folder to store all of your stuff in, and start putting your project charter in there and your Gantt chart in there. And then we'll talk about design notebooks today. So those, if you're doing it electronically, will go in there so you can store everything and all have it in one place. For your project this week, so you'll be working on finishing up your project charter and your Gantt chart, and you will be able to come back to these if you need to revise them. And then we're going to start talking about the design process today. So things that you can start thinking about and working on, and we'll especially do some of that on Thursday, are your problem statement, and then thinking about who your customers are, who your stakeholders are, interviewing them, figuring out what they want, what they need, etc. And we'll talk about more of that on Thursday too. And you will begin your design notebook this week too. So if you don't have a notebook and you're going to do a hard copy, you're going to have to get that. You'll want it by Thursday for sure as we start the design process. Now today we're doing 3 different lectures at 3 different times. So this one you're getting live, and the other 2 are on Chapter 9, which is technical writing, and they will go over memos in that section too. So that might be something you want to look at and listen to before Friday, so you know how to write a memo. And then ethnographic research is the other one this week. So you can listen to those, and those will help you think about how you might want to interview or observe your community partners. All right, so are there any questions on sort of the craziness of today?
When are these sections if we actually just want to go to?
They already have it, sorry. Yeah, this class is from 8 to noonish, Tuesday, Thursday, so the other 2 sections will happen today. So you'll get to watch those videos. All right, so you'll want to watch those videos sooner rather than later. They might help you with the quiz if you didn't understand the reading as well. But you can take the quiz doing the reading, and all the stuff you'll want to get done sometime this week, and we're going to jump into our projects then. And one last thing, please email all instructors when you are contacting us electronically. We are just going to start ignoring anyone who just emails one of us. It does not allow for us to, we're in this all together, we're teaching it together. It does not allow us to properly communicate with each other. We have to like forward emails and talk to each other and try to remember to make sure everybody's on the same page. And as an added benefit for you, you are likely to get a faster response because you're emailing all 3 of us. Okay, so if you email one of us, we're going to just start ignoring that you even sent an email. And so we don't want to do that, so please just email all of the instructors on the same email, carbon copy, and we will hit reply all, and we just keep hitting reply all until it is resolved, okay? So email all of the instructors. So if you're going to miss class, email all the instructors. Even if you know exactly who's going to teach, maybe we'll change things up, but make sure you email all the instructors. If you have any questions, email all the instructors, okay? Please, please, please. All right, we're gonna jump in now and talk about problem solving, which is a process. And this is all about chapter 4. We have an engineering design method, and we have talked about it in chapter 4 in the context of service learning. This topic is something that we're gonna revisit throughout the rest of this course, okay? This is an introduction today of what this process looks like, and this is what you're gonna apply in your projects. And so we're gonna walk you through and give you tools to follow this design process. So what you wanna take from today is to be able to define engineering design, appreciate the importance of this process, and how it can hopefully help you resolve some of the challenges of design before they happen. Thus, understanding the need, why we have this formalized design process itself, without just jumping in willy-nilly to get to the end solution. And lastly, you're gonna wanna name and briefly describe the steps of the design process. So that as we go throughout the rest of the course, you can come back to this point, right? You know what the design process is, and when we start talking about different parts of it, you can remember where we are in the design process. And it will be especially important because the design process is actually iterative, so it's not very linear. It's very cyclical, it's gonna repeat itself, so it can get kind of crazy, all right? It's not just one straightforward, follow this line, bam, done. It's gonna come backwards, around again. But if you can name all these steps, then if you have to come back, you can remember where you are and where you're going. All right, so let's define design. What do people think about when they hear the word design? How would you define it?
Hard.
Hard?
Layout.
What is that?
Layout.
Layout?
Yeah.
So this is Donnie?
Yes.
And not. Anything else? All right, we have actually a formal definition given to us by our accreditation board, ABET accreditation board. So it's the process of devising a system or a component or a process to meet desired needs. So we are solving a problem when we do design. We are meeting some sort of need. It's a decision-making process, it's iterative, so it's not gonna be linear, it's gonna be cyclical, and we're gonna pull together all sorts of different skills. So basic science, math, engineering skills, and you'll create either a new product or an improved product that's going to be more profitable or benefit society in some way. So we're doing this not just for the money, but also to help people, to meet people's needs. And things like art can also be very useful, and as we talked about, team management, management skills, project management is also useful. So art, science, management, we're going to put all these skills together into an iterative, systematic process. There are 3 different levels of design. So design does not always mean that you have to create something totally brand new, right? You don't have to come up with some $1 million idea. In fact, you can have an adaptive design. So maybe you're using something and there's some minor tweak to it that would make it better, right? So you can take some existing design and tweak it a little bit, or maybe there's some major thing that you can add to it or modify on something that already exists that would make it better, all right? These are all ways to design, so you don't have to come up with something completely new. You can build off of other ideas or even just modify them slightly. Now, one of the important things about the design process, and really its greatest challenge, is our customers or end users, or sometimes we also call them stakeholders. So there's going to be a few terms that we kind of use interchangeably, so if you're ever confused, do raise your hand. So consumers, end users, now they may tell you what they want or need when you interview them, but there are certain things that they're always going to care about, and they may not necessarily articulate all the things that they care about or articulate it in a way that you can take with you. So you're gonna have to do some decoding essentially of what they say, because they do care what it looks like, even if it works amazingly. If it's ugly, they're not gonna wanna touch it, right? They're not gonna wanna pick it up, they're not gonna wanna think that it's gonna work, even if it does work amazing. It has to be reliable. So we gotta have high quality here. Somebody doesn't wanna find something that you made, bring it home, use it, and it breaks right away, right? That's not gonna be good at all. And they do care about cost, okay? They're not gonna pay tons and tons of money, even if it is really awesome. Although there are consumers out there who will pay a little bit more for a really good, high quality product, right? So you gotta think about cost too. And the biggest thing about cost is during this design phase that we're gonna be working on, if you're running a company or something, this is the best time to try all sorts of things out, because it's the cheapest time from a company perspective, right? Once you start manufacturing something, if you wanna change it, think about redesigning an entire plant to remanufacture something in a different way. That is gonna cost a lot of money, right? It's gonna be a lot harder to change things when you're further down the design process than in the beginning. Okay, so the beginning of the design process is so important, and we will spend a lot of time on that. I know you're gonna wanna jump in and try to think of solutions right away. Hit pause, okay? We're gonna go through the process systematically, and it will be smoother in the end. All right, so Najim said design is hard.
I said it is an art.
Oh, is it an art? Oh, I apologize. It is an art too. And it's hard. Okay, so you didn't say it's hard, but it is hard, and it is an art as well. And we fail as engineers, okay? In 1981, there was a hotel walkway that was elevated, collapsed, killed 200 people, injured a bunch more. In 1986, the Challenger space shuttle had structural failure and 7 people died. In 1996, Chernobyl, which is a nuclear power plant in Russia, bad design and people doing some safety tests that were not following procedure led to a meltdown and radiation release. Here we had 49 direct deaths and then a bunch of cancer cases and premature deaths, and also a bunch of people had to move. They couldn't live where they used to live. In 2003, the Columbia space shuttle crashed and 7 people died. And not all of these things happened in the past, all right? They are still happening today. In 2018, there was a pedestrian bridge in Florida that was being constructed, and it collapsed on a bunch of cars that were sitting at a red light underneath it. So engineers fail, and they're failing today.
Did that come from materials used?
You know, I haven't looked it up since this last summer to see if they have any reports on it, so I don't actually know at this point exactly what happened. I know that they were trying out a new sort of construction process thing, but yeah, I haven't looked it up, sorry. It would be interesting. I'll have to do that for next time. And 6 people died. So engineers are still failing, and you will fail in your projects, okay? Hopefully, you will have something at the end, but along the way, there will be failures, okay? And here's some reasons why engineers would fail, all right? We might make assumptions, they're incorrect, maybe we didn't understand the customer, maybe there are some errors on drawings. Who knows about the Mars rover failure? Nobody died there, but there were 2 teams working on different things. One was in English units, one was in metric units. They didn't tell each other, and the whole project, I forget how much money went down the drain because it didn't work when it got out into space. So here's a bunch of different reasons why engineers fail. And so design actually is hard, okay? We are trying to predict what's gonna happen, predict the future, okay? That's a hard thing to do. So, enter a systematic process to hopefully eliminate and help us fail less and fail less spectacularly, okay? And hopefully we'll fail during the design process so that at the end we have something that should not fail. That's the whole goal of the design process, is to solve a problem, do it well, and not fail at the end. All right, so we have some basic principles for our design. How many of you have seen any little kids sort of like STEM toys or projects? No, nobody has kids or what? Erector sets. So these days, a lot of different kids' toys and products are trying to incorporate the engineering design process in them. So you might have seen things like that say ask, imagine, and create, or sometimes it's a little longer, ask, imagine, plan, create, and improve. So these concepts, that's the general basic principle for the design. So we have to think about what are our requirements, what are we trying to do, what are we trying to solve. We'll come up with some ideas, and then we'll dive into the details of the design. Okay, so these are just the basic principles of this whole systematic design process. Now, this process is not some sort of like mathematical model. We don't have an equation. We're not going to follow it. It is not linear, okay? But it is systematic, and it will iterate on itself. So there is a process to it, right? It's not just willy-nilly. There's some purpose behind it. And what we're really trying to do is address a problem, so we are going to hit pause and postpone our solution, okay? So don't start thinking of solutions yet, because you won't be able to solve your problem until you fully understand what it is. All right? So this beginning part, defining the problem, understanding our customer, our stakeholder, that is the most important, okay? And the customer or stakeholder or end user is somebody, like everybody who will deal with what you're working to design. Every single person, okay? So it's not just the person who is going to buy it off the shelf. Not just that end user is our customer, okay? Everybody involved in the process. This would include people who are going to manufacture it, so the people who will be in the plant making it, right? This will be the CEOs of the company who are going to want to fund it, right? So all sorts of different people are going to be stakeholders. For you all, you have added stakeholders of your instructors. We are stakeholders. There are certain things that we are expecting of you, right? We are going to expect you to write reports along the way, things like that. So we also are going to be stakeholders for this process. All right, so I've been talking a lot, so let's let you do some interactive thinking now. How about a tree swing? Let's think of all the possible customers or stakeholders for a tree swing. All right, so we have a tree, and we're going to add to it a swing, okay? A kid wants to swing on a tree. Who are all of those stakeholders and customers? So just take a few moments and think about who they are. Everyone.
Kids.
Not just the kid. Everyone who you could guess. Let's take some time to brainstorm before we shout out answers. Give people who need a little bit more time to think. If you want, you can jot it down so you can remember them. So I'll give you a minute and then I'll take some shout out answers. All right, let's just shout out a few answers here and I'll write them down or over here for the camera. What do we got?
Customers, public,
Public?
yeah,
Can you be more specific?
like people,
Oh, the people who walk by.
yeah.
Okay. Passerbys? I don't know if that's how it's spelled. People who pass by. All right. Who else? Who? Who are the consumers? A park? Park managers?
Property owners.
Property owners? Go ahead and just shout them out.
Maybe like landscaping companies, because I can see an increase in like tree sales.
Landscapers?
Let's say high school managers or directors.
High school managers? What about the kid? That's gonna swing on it?
Parents.
The user? Maybe an adult? Insurance company. All right. Any last ones? All right. So here is a fun cartoon of a bunch of different possible customers or stakeholders. We've got a client, somebody who's going to sit on it. They want a nice cushion pillow. They want it to cost $0. Here is how the client explained what they wanted, and it wasn't really interpreted quite well. We've got multiple seats there. The project manager understood it to be a swing that runs into a trunk. So we've got all sorts of different people thinking, ooh, and it was delivered in the winter, that's no good. You gotta be very careful and describe exactly how to build it, because there's a contractor who's gonna build it, right? And if you don't tell them how to build it right, it may look bad. The client maybe paid a ton of money for it and expected a roller coaster. Maybe the client received it and it didn't get put together. And maybe all the client really needed was just a tire and a rope, right? So you have to think about who are all these stakeholders and think about what exactly should be the end, right? And there's really not going to be necessarily a right or a wrong answer, okay? And there could be multiple right answers for different people, and you have to kind of think about all of these different stakeholders and come up with something that's going to meet everyone's needs, okay? And there are a lot of other good ones up here that didn't show up in the cartoon, okay? So that's going to be the beginning of our design process. It's a very important part, okay? So let's look at the whole process then. There are a lot of different graphics or words that are used to describe this process, and they all come back to those basic design principles, okay? They come back to requirements, concepts, and a detailed design. That's that ask, imagine, and then create, okay? Dr. Procyse, this is her favorite one. All right, it's nice and color-coded too. So we're going to see some of these colors pop up later where you identify a problem, you develop specifications, so exactly what you're going for, the exact needs that you want to meet. You come up with ideas, you do some detailed design, you think about what happens when you deliver it, so you have user manuals and maintenance to think about, and possibly redesign or retirement. What's going to happen when the user is done with your product? Can you recycle it? Does it get thrown away? And this whole process is iterative, see? So you can cycle back around all day long, okay? So we're gonna talk about it in a linear fashion because that's all we can do, but you will revert back to a bunch of these different steps. Now we also have, oh, my animations didn't work, a bunch of different things if you look online. So this is a fun one where they've created a design process game. So you go along and you just follow the steps that happen in all of these different things, and there are some spots where you have to go back. So you made some sketches of some designs, and then you gotta go back and do some more brainstorming and keep going forward again. So there's a lot of different graphics. So if you find one that resonates with you or that you like, feel free to sort of follow that and see how it matches with what we're doing. They're all basically the same, okay? They come back to those design principles. This one I thought was really fun. And this one is really boring. But I haven't found anyone who has an acronym for their process. Some people have distilled it down to just 3 steps. But the design process takes a little bit more, so there's a lot to then those 3 steps. This, so far, is the best that I could come up with that has an acronym. DIP and PIP. And this problem-solving process, it's a problem-solving process, so if you've had me for other classes, I've also incorporated it because you can use it when you're solving problem-set problems for heat mass transfer or thermodynamics, those kinds of things. So what you do is you define D, so you ask, what's the problem? You're gonna listen to the voice of the customer, figure out exactly what you need to do, all right? Who are your stakeholders? What do they need? What do they want? And then you're going to identify specific constraints or requirements or criteria that are measurable that will mean if you've met them, you are successful, okay? And so the last colorful one, that's essentially this whole portion right here, defining the problem. Next, now you can start thinking about solutions, okay? So we're gonna spend a bunch of time defining, and then we'll start thinking of solutions. So we're gonna brainstorm, and then you're gonna select winners, okay? Select things that meet all of these criteria that you define the best. All right, and it's a process. You don't just say, oh, that one seems like it will work, okay? We're gonna walk through and figure out how you can best select the best idea. And it's an iterative process, so you'll start from really coarse ideas and then move to finer and finer detail, okay? So when you first go through this process, it's gonna be higher level ideas, just general concepts, and later on, you may break it into different components or subsystems or modules, and do some more detailed design on those different subcomponents. Plan, at least as an engineering student, planning can happen a little bit later, but planning really happens throughout this, right? We already are planning things that have to do with the team roles and how to make a decision, coming up with a schedule, but you're gonna revisit this plan all the time, okay? So you're gonna come up with, as your design gets further into the process and further into the details, you're gonna have to keep updating all of your planning tools again and again and again. Once you have selected some sort of a concept, then you're gonna do prototyping. So you're gonna build it, and you're gonna test it, and you're gonna analyze it, and see how well you're meeting these criteria for success that you've defined. Okay? And it's going to be iterative, so you'll have several prototypes. You may have one that's just made out of pipe cleaners and straws and tape, okay, just to see how it works, see how it might function and move together. And then you may move on when you get into more detailed design and start building it out of actual materials, okay? And you may build smaller size models, scale it, right? Those kinds of things. And so then we get to iterate. So I've already said we are iterating. We're going to start over from the beginning and go from this high level down to the finer and finer details. And throughout this whole process, we are going to reflect and redesign. we're gonna keep going back to the different parts, making sure that as we move forward and give a prototype to maybe our community partner, we may get some feedback and like, oh, we totally missed some specific want or need of our stakeholder from the beginning. Whoops, okay, let's add that in and relook at all of our ideas and see how to move forward. And lastly, you will communicate. And so here, this includes delivering your system or your product or your process and documenting it, all right? So for this class, some of those things are gonna be reports. They're gonna be your engineering design notebook. You're gonna have a manual, bills of materials, all sorts of things that are gonna document what you've done. And after we talk about this chapter 4, we're gonna go back and talk about this communication, specifically reflection. And then one of the other video lectures you can watch is all about technical communication. So we'll talk about reports and memos, that kind of thing. All right, so let's look at some of these a little bit in finer detail to see what exactly you are going to be doing in the future. So in the define portion, you're gonna identify the project problem, okay? So what is the need that needs to be met? You're gonna conduct needs assessments, identify who all of your stakeholders are, define what things those stakeholders require, what they want, what they need, and determine any constraints of the project, like time, money, that kind of thing. And you're gonna want to make sure that you listen to the customer, okay? So you're gonna ask them things, you're gonna maybe just observe them, interview them. You probably won't do focus groups, but this is something you could do. Focus groups, you can do role playing, you can interact with each other, yourselves, and maybe even build some simple prototypes. The other topic that's a video lecture, we'll talk a little bit more about how you can do some ethnographic research, which has to do with asking and observing and interviewing people. Once you have the voice of the customer, it's spoken in their language, you have to translate that into your language, the designer language. And that means you need to come up with measurable specifications, quantifiable, think SMART goals, right? Specific, measurable, those kinds of things, so that you can actually tell that I need it or not, okay? You will think about who the stakeholders are, so just like for the tree swing, for your project, think about everyone who will be affected by your project, all right? End users, clients, insurance companies we wrote, people who manufacture it, all those people are ones that you want to think about when you're designing and coming up with exactly who will interact with it and what do they want or need out of it. The more that you can meet, the better your product will be. So here's an example of what a problem identification would be. A bad one, a good one. Need a chicken containment. Okay, we're gonna contain some chickens in something, right? Well, that's not very descriptive, right? Here's a good one. Design a chicken coop that will increase egg and chicken production using materials that are easily obtainable and maintainable by locals. That's a lot more descriptive, right? Now we know why we're actually building a containment, like what its purpose is, okay? So you want to make sure that your problem identification includes some more details. And here's the best one. So now we're talking about who the organization is. They would like the team to design and produce a chicken coop used by several families in a small village in Guatemala. Now we're getting more specific. Who are those local people and what materials might be available to people in a small village in Guatemala, right? Now we learn about the climate, the temperature that's happening there. There's volcanic soil, there's a certain level of sea level, and they have rainforests all over. So we're learning, this problem gives you a lot more details about how you can possibly solve building a chicken containment, right? So we're going from just a very simple, which is what we gave you, right? We gave you a bad problem, right? That is not well identified. So you are going to come up with redefining exactly what that problem is and coming up with a better problem statement. Then you can talk about the specification development. So once you know what the problem is, what needs must be met, you can think about then going through some of these different tools of defining what your user needs and coming up with specifications that are measurable, so criteria that you can evaluate. So when you come up with an idea, you can compare that to your criteria and see if you're meeting your user needs. This is what you will be working on Thursday, this stuff right here. So that says requirements and specifications. So on Thursday, you're going to talk about what are the main functions or sub-functions of what you're trying to do. Come up with successful criteria that will meet all the that can be applied to all of your possible solutions. You're going to want to make them quantitative whenever possible. So those are smart, measurable things. And you want to think about technical, environmental, ethical, health and safety, all the things that your stakeholders might be concerned about. And you're going to come back to these specifications. Whenever you come up with ideas, you're going to compare them to these specifications, and you may need to refine them as you go along. Maybe add some or tweak some a little bit. And now we get to the fun part, right? The part you probably have already started thinking about, but I want you to not think about it yet. Coming up with solutions. So you're going to ideate. So you're going to brainstorm. We've got different possible tools that you can use to just do brainstorming itself, okay? And a thing called functional decomposition that you can use. And you can even build prototypes at this stage, right? To just kind of visualize and get your mind wrapped around different ideas that you have. And so this is what we call a proof of concept prototype that will really help you determine whether what you have picked moving forward is going to be feasible. So you're going to pick one at this point, all right? And there's a process that you can go through to pick one and compare it to your criteria so that you're not just sort of all coming up with a very, very subjective, I like this one the best. Once you have picked out one idea that you think is the best, you're going to then go to the prototype, test, and analyze phase. And so here's where you do some more detailed design and come up with a more detailed prototype where you might start using materials that you're actually going to build your prototype out of, so that then you can do some testing in the field. So either with yourself or hopefully with your actual customer, you can get some feedback about how your design is actually working. And we will always be iterating, okay? So as you build your proof of concept prototype, maybe it didn't work out so well and you go back and use a different, maybe your second best choice, right? Or maybe once you build the actual prototype, you did some sort of testing and there's some major flaw that you recognize. Now you have to go back to a further part back in the design process and see how you can overcome that flaw. So we're going to be doing this pretty much at all the stages. You can go back to the beginning and you can always be more detailed, okay? Always be more detailed. So you can do this whole design process really high level and then move into the finer details. And lastly, we're going to communicate or reflect. So throughout the process, you're going to be documenting what you're doing because we're going to have you do reports along the way. But you also have a user manual for your end user. Maybe talk about some service and maintenance that they can do. This is when you'll deliver your actual product with the manuals and really reflect and think about, did we actually succeed at what we set out to do? Did we meet our specifications? Is our customer happy? Those kinds of things. We can always make things better. So you will also reflect on ways that you might be able to improve things in the future, okay? And don't take that reflection of making it better as a point of failure, okay? Everything can always be better. Anytime I write anything, anytime I prepare one of these classes, I always think about what could be better the next time, okay? So don't take it personal as it's like you failed, all right? But you do want to reflect and think about how you can always be better. Okay, so that was a lot, right? But dip and pick, okay? Define, ideate, plan, prototype, iterate, and communicate. All right, so that should hopefully help you remember. And we're gonna go through all this stuff in greater detail, sort of step by step, although it is cyclical, so you can go backwards a little bit sometimes. But we're gonna go through each of these parts with you in more detail and give you tools along the way to be successful, okay? All right, any questions on all this? It's a lot, I know. So we're gonna break it down for you. And we're actually gonna start sort of at the end of the process to break it down for you. We're going to start with that communicate, reflect, the very end of our design process, and then also one of the other video lectures also talks about technical communication. So we're going to start talking to you about the end of the design process so that you can use this as you go along in your design process. It'll be much easier to document as you go as opposed to doing it all at the end, okay? It'll make writing those manuals, writing those reports that much easier if you at least have a general sketch and, documented stuff you've done. So we're going to talk about reflection in the context of engineering analysis. For this chapter, this is chapter 3, you want to understand the importance of reflection, list different forms of reflection, be able to use at least one of the models of reflection that are in your book, and then implement a design notebook. That one you'll be doing throughout the whole course. So, what is reflection? Who thought they'd ever hear reflection in an engineering class?
Oh, God, sorry, there's more like that.
You have?
Yeah.
You thought you would?
Yeah.
Oh, interesting. So, I never heard this term, I don't think, reflection, or at least it wasn't like the topic of a whole chapter, but I did learn engineering reflection as a student, okay? But, I don't know, when I think reflection, I think liberal arts classes, humanities classes, more sort of feely, touchy kind of things, right? The warm, the fuzzy. So that's not exactly what we mean in engineering. We have lots of different forms of reflection. It's really just communication, okay? Reflection is really just communication. So they can be technical reports, maybe some sort of drawing, maybe an oral presentation, an engineering design notebook, or maybe sort of a group meeting or a focus group kind of thing, something like that, okay? So all these different things, they're forms of reflection, right? Getting feedback, thinking back on what happened and how it can be better, right? If you write a formal report or do an oral report, you're documenting the process, this is what happened, but at the end you always talk about what results you got and how it went and how it could be better and those kinds of things. So you are actually doing a reflection and thinking back on things. In this class, we will do an engineering design notebook. So you're going to start that now, all right? What this does is basically documents your design process, okay? Anytime you do any sort of experiments or research or investigation or design, you're going to want to have an engineering design notebook. And you're going to just document everything. So at the end of every day, I highly recommend you think back on the day and put an entry into your engineering design notebook. Okay, this is not like writing a diary. Alright, but if something came up during the day, you didn't already put it in your design notebook, you're going to want to do that, okay? Both your failures and your successes, all right? History, if you don't know your history, it's like you were born yesterday. So if you don't know what you've tried and failed at, you might try it again and forget, right? And you're gonna put every detail of the design process in here, okay? So throughout class, when we do stuff, when you're in your group meetings, when you're at home. You're gonna make sure that you put all the stuff that you're doing for the project into your design notebook. So it's gonna be chronological, all right? So you're gonna number every page, you're gonna sign every page, you're gonna date every page. And this can also be used for, if you come up with something super amazing that nobody else has ever thought of, you can patent it, okay? And by signing and dating it, this is what inventors do to say, this idea is mine. I thought of it on this date, so if somebody else thinks of it a week later, you've documented, okay? This is something that you can use to prove that you are the rightful owner or thinker or idea creator of something, all right? So you want to make sure it's organized, legible. Other people are going to possibly read this. Definitely in this class, other people will read it. The instructors will read it. You want it to be easy to understand, all right? Not too super technical, and definitely you want it to be complete, okay? You don't want to be missing steps, especially if you are trying to make something more of it than just this project class. All right, and don't forget to give credit where credit is due, all right? You can put stuff in your engineering design notebook that's not yours, right? But you have to say where you got it from. A lot of times, let's see, in writing classes, have you ever been given like the first sentence out of a book and then you're supposed to keep going, right? That first sentence, that's not yours. You have to indicate where that came from. So in design, that will happen all the time, right? Especially if you're doing that modification to an existing design and making it better, you have to document where the originality of the design started, okay? So what do we put in our engineering design notebook? Any ideas that you brainstorm, maybe some commentary on those ideas, or commentary on data and analysis. So if you do testing, if you have an interview with your community partner, those kinds of things you're going to want to put in there. You're going to put your problem identification in there, specifications, we're going to do decision matrices, all sorts of stuff. Okay, so you want to put that all in there. Pretty much everything. So at the end of every day, I just recommend you think about stuff that you should maybe put in there, and it'll make your life that much easier. We are going to be doing periodic reviews of your design notebook so that we can help you use it to the best that you can. Make it the most useful for you, okay? We're going to review your design notebook periodically throughout the semester, help give you feedback to make sure that you're using it in the best way to help you be successful. We actually have a rubric already made for this, so you will know exactly what we expect of you, okay? So there's a part on organization and presentation, a part on just what content is in there, specifically a part on data analysis, and some on creativity. So I recommend that you go ahead and look at that design notebook rubric before you start and maybe refer back to it a few times. If you're gonna, you have two choices. You can do a hard copy, and here you're gonna wanna have a bound notebook, okay? Not one of these, where you can put pages in and out and sign them and date them whenever you feel like and put them in whatever order. This is really a document of what happens over time, okay? So you're gonna sign and date all the pages, or you can do it electronically. And if you do it electronically, you're gonna use a Google Doc. So just like a writing, like Microsoft Word, but the Google Doc, okay? And you will then put that in a folder for your team. So it's your choice. Think about which one you want to do, because you're going to want to have it ready to go for Thursday. So on Thursday, we're going to start doing stuff in the design process, and you're going to want to start documenting, okay? So either electronically or a hard copy in a bound notebook.
Is this individual or just one?
Individual.
Okay.
Individual. So if there are ideas that came from other team members, you can give them credit. So there will be stuff that will be in everybody's notebook, okay? But there will be a lot of stuff that's just in yours. So when you're brainstorming a bunch of ideas, a bunch of them will be just yours, and then your teammates may come up with other ones. And as part of that process, we're gonna do a decision matrix. Everybody's notebook will have a decision matrix, and it'll be the same. But the ideas that were generated before you get to that decision matrix will probably be different. And you will hopefully split up some of the work too. So, everybody's will not be the same, but they're definitely, these are individual, excellent questions. All right, so think about what you want to do and pick by Thursday so you can start off on the right foot. If you are doing a hard copy, know that you must have like a table of contents and things, so you're going to want to skip a bunch of pages at the beginning of your hard copy notebook so that you have enough room to go back and write them in later. Okay. So skip a bunch at the beginning. There's a bunch of front matter that you need to include, so you're going to want to put your name, your phone, your email on it in case you lose it. They can find it. Who's in your group you probably should put in there, your project community partner, their contact info. So it's really a nice place for you to go back and refer to if you need to contact somebody, and then make sure all your pages are dated and signed. Lucky for you if you do the electronic one, Google tracks all the stuff that you did. So not so necessary to date and sign all of those, but definitely make sure all the pages are numbered in their changes so you can build a table of contents later. Any other questions on the engineering design notebook? You can take class notes in it if you'd like, so it doesn't have to be completely separate if you want to keep it all together. And you should do headings for the page, so you want to be organized, so think about it, because you're going to use this as a reference, right? Let's say you brainstorm a bunch of ideas, you go ahead, your team builds one, it doesn't work out well, or maybe there's one piece of it that doesn't work out well, but you can go back to your brainstorm ideas that you already have documented and be like, oh, did we have an idea already that addressed that problem? Okay, so this is not just for us to see how you're doing the design process, but it's for you too, okay? So you want it to be organized so that you can actually use it efficiently. All right, does anyone remember the 3 models of reflection? Any of them? It's been a while, because we were supposed to talk about this last Thursday, right? So you probably read it like a week and a half ago, maybe, a week ago. Anyone remember any of them?
There's one that's like what now?
Yes, exactly. So the so what now, that one? Anyone remember any of the other 2?
Someone started to see.
Yes, some Polish-ish looking name that starts with Z. Yeah. And does anyone remember the last one? All right, so we got the what, so what, now what, which is essentially we're going to describe, examine, reflect, contemplate, and analyze. So you're going to I like this one a lot because you just kind of remember these 3 questions, right? And that helps you really do a good reflection. What, more objectively just describe, so what, and then what are you going to do moving forward, right? And the other one is ORID, which stands for objective, reflective, interpretive, decisional. They're all essentially the same, right? They're all getting at the same thing. So the objective part is like describe and examine, right? Same kind of thing. Reflect, reflective part. Interpret, so you're going to contemplate, analyze, think about what's moving forward, is decisional, okay? So they're basically the same. So whichever one of these, and the last one is Slokowski's levels of reflection. So whichever one resonates with you, okay, whichever one makes the most sense for you, go ahead and use that one to help you do reflections, okay? But you really want to get at sort of the 3 different levels, 3 different things. Because so Slokowski also has 3 different levels. So this is very objective, the technical specification part. This is sort of like more of the warm fuzzy, the feeling, so what kind of thing. And lastly is more of the now what. So how does this affect society and issues within, okay? So they're all generally the same. So when you're gonna have to write a reflection. And so just to demonstrate these models, and then you'll use sort of these same kinds of questions throughout the design process. Whichever one of these works for you, okay? Whichever one resonates with you. There is no wrong answer. I have a few questions for you though, to see how you're thinking about reflection. See if you're comprehending. So, how is a technical report a reflection? Feedback? What do you mean by feedback? Situation? So a technical report, something went wrong, did some maintenance or fixed something, and then made some sort of improvement, so now what do you do? So it does come back to these models of reflection, right? They have described the objectives, they explain things, they're more reflexive, contemplative, sort of like, why did it go wrong? And then, how can we make it better in the future, right? So those models, they're being used within a technical report. You will use it in your technical report. All right, what do you do after class finishes today? And what should you do after class finishes today?
Go to classes.
All right. Scott, you want to do it? You haven't said much. All right. No? All right, anyone else?
Maybe
Furkan?
watch
Watch the videos? So today is special, you do want to watch the videos. Okay, what if we didn't have other videos to watch? It was just this, just for today.
design notebook.
Design, think about what you might put in your design notebook, which is a form of reflection. So really after each class, you should think about, did I understand everything? Did it make sense? Do I need to get help? Do I need to read up more on some kind of things? And every day after class, I think about, how did that go? What could I make better, okay? And I write and I've got a document for all of my different classes where I write in it things that went well and things that didn't go well, and if I have any ideas on how to make it better in the future. So I'm doing this, we're all doing this, all should be doing this. How about this one? Why do athletes, I think we got a lot of athletes in here, why do athletes watch game tape?
Learn from your mistakes.
Look for mistakes, see what they need to practice on doing. So they are also reflecting, okay? So this warm, fuzzy reflection is very broad, right? It's not necessarily all just warm, fuzzy, feely stuff. It's very important, right? So, the last thing that I have for you is for you to practice reflecting. So we're going to do this thing called mind shift and practice being other-centered. And this fits very nicely into service learning and working with community partners. So, your challenge is to practice being other-centered for a week. So usually we're very me-centered, focused on just, what do I need, what do I want? And sometimes that can be a good thing, right? You need to stay healthy, think about yourself sometimes. But you should really also think about others too. So let's say you're standing in line at the grocery store and somebody in front of you decides that they're gonna pay in cash and coins, right? So now they're digging into their pocket, trying to find exact change, and you're just sitting there like, oh, I just wanna get out of this store and go home and make my food and eat dinner, right? So that's very me-centered, like hurry up, come on, get through the line. Maybe try to be other-centered, so practice this is your challenge for the week. And just be like, you know, that's all right. This person is gonna pay with cash, that's cool. I'll just, you know, stand here and maybe read a magazine, or no big deal, right? Don't get stressed about it. So try to practice being other-centered this week and be just respectful and contemplative of other people around you, all right? And then write a reflection about being other-centered. So use one of those three models, whichever one you'd like, and write a reflection about being other-centered. And this will be due, this is individual, it will be due in a while. Not this Friday, but the next Friday. All right, this Friday you're working on Project Charter, Gantt chart, that kind of thing. So, and you have a week to do the challenge to try to be other-centered. And to help you, we also have some critical thinking questions for you to help you go through some of that reflective process too. So if you need some prompts, you can think about these different questions. I've got 3 of them there for you, and they kind of sort of follow the different models, right? We have well, before that, any questions on reflecting, or engineering design notebooks, or the engineering design process? If you are not sure what you're doing, do please ask, okay? Better to ask earlier so that you're doing things correctly as opposed to forgetting something. Okay, so we have about 10 minutes. We're gonna get into our project teams, exchange contact info, and start working on basically forming your team, all right? If you need a computer, we can get a computer out if you want to start creating a little drive or working on something. But at the very least, meet your team, get their contact info, maybe find a time that you can start meeting weekly, and a time that you can work on things.
حقك يا unbreakable chance.
Does everybody know who's in their team? And you probably might not even know each other.
ايش اسمه ذاك؟ يا هذا مجيد.
We're still